Okay, so in lesson 7.6, we're going to be still looking at similar triangles, and we're going to be looking at proportional lengths in those triangles. So we're going to have a few theorems to help us out with this. The first one is the triangle proportionality theorem, which says if a line parallel to one side of a triangle intersects the other two sides. So our picture is we have a triangle, and there's a line that's parallel to one of the sides, and it touches the other two then. It says, then it divides those sides proportionally. So that means that we could set up a proportion of A over B is equal to C over D. We did stuff like this the other day, saying that in that picture there's two similar triangles that are stacked inside of each other. But when we set up the proportion, we did little to big, thinking of the triangle sides. So we would have to set up a proportion that would start something like A over A plus B, and then C over C plus D. So we were thinking of whole sides of triangles. This theorem says it actually works out a little bit nicer than that. We can just do the broken pieces. Okay, so we can do top to bottom, top to bottom. The corollary to this says if we take three or more, really, parallel lines and cut them with transversals, those pieces they cut off will be in proportion just like it was in the triangle, A over B and C over D. The reason why this is a corollary is what we could do is look at the case where, let's say those lines just intersect and close each other up, then we would have the theorem. So if the theorem works, it must work when we kind of separate and open up those lines still. Questions on those? We have one more theorem then, which is a triangle angle bisector theorem. And it says, if a ray bisects an angle of a triangle, so I have a triangle, I have a ray that's going to bisect an angle, cuts the angle into pieces, then it divides the opposite side into segments, so we break up that side, that are proportional to the other two. So we could set up broken piece over broken piece equals whole side over whole side, and we just want to make sure that we do it so that stuff matches up. So since A was the top broken piece, we would go with the top full side. And B is the bottom broken piece, so then D is the bottom full side. Okay? Questions on that theorem? Okay, so then we need to look at some examples of how these problems will look on your assignment. For this one, we want to complete the proportions with words. So we have this picture where we have a triangle and we have a parallel line cutting through. That means we have two similar triangles there. So this first proportion is like what we did the other day, where we say upper left, well, that's the side of the small triangle, to whole left, that's the side of the big triangle. That would be equal to lower right to, so lower left to whole left would be lower right to whole right. We just want to match up so we're doing the same things. So lower to whole, left to left, right to right. So we just want to match up the same stuff so that we're doing the same thing on both sides of the proportion. So upper left to lower left would be
upper right to lower left.
Upper right to
Upper left.
Lower right. So we're doing the same stuff. So upper over lower, left over left, right over right. Okay, so we're matching up the same type of things. For the bottom one, it says upper left to whole left. So this is like what we were doing the other day. Upper left is part of the small triangle. Whole left is the side of the big triangle. That would be equal to upper parallel over lower parallel. The parallels are a little bit of a different case because they don't have parts to them. The parallels are not broken pieces. So whenever we consider the parallels, it is important that we consider upper to whole. This is a super common student mistake. I cannot emphasize this enough. When you're dealing with the parallels, you must be working with upper to whole, not upper to lower, because the lower part is not actually a piece of a triangle. It's just a piece of a side of a triangle. It's not a full side. Okay? So when we're dealing with the parallels, we have to make sure that we're doing small triangle to big triangle, just like we did the other day. And what else would this work with? What else could we set this equal to?
Upper right and whole right.
Upper right and whole right. Okay. So again, really, I can't emphasize this enough. So I'm going to show you. We'll put some letters in here. A over B equals C over D is not true. Okay? When we are working with those parallels C and D, we cannot just do upper piece and lower piece of a side. What would we need to do if I wanted to solve for something like C or D?
We need to create a ratio of A to B, and then from that we can decide that the parallels have to go with that ratio.
It wouldn't work with the ratio of A to B, because B is not a side of a triangle.
Would you go A over A to B, A plus B?
A over A plus B. This is where we would need to consider upper to whole, like we did a few lessons ago, where we're saying compare small triangle to big triangle. Okay? So when you're dealing with the parallels, you cannot deal with just the broken pieces. We need to be doing small triangle to big triangle. Okay? All right, on these ones, we want to set up some proportions. So in this first one, we have an angle bisector coming in. That's what those little marks in there mean, that those two angles are equal to each other. So what would be a proportion that I could set up for the sides?
Are you talking about the N and A one?
Yep.
Okay, you can do N over A and G over B.
Yep. There's a lot of different orders that we could do, a lot of different proportions we could set up. We just need to make sure that we're staying consistent in our matching. So N over A is broken top over the full top, and then G over B, broken bottom over the full bottom. Okay? We could also do something like N over G would be equal to what if I started it out that way?
A over B.
A over B. Okay? So there's a lot of different ways we could set it up, but once we pick that first pairing, then we just need to do the same thing for the other pairing. Okay, looking at the other one on the top now. Again, this is another angle bisector problem. What proportion could we set up here to solve this?
X over 6 equals 10 minus X over 9.
Mm-hmm. Okay, so we're matching up pieces. Broken piece to the side that goes with it. Broken piece to the side that goes with it. Then what would I do if I wanted to solve this? Cross multiply. So I would get 9x equals, what do I need to do when I do the other cross multiplying? Distribute. So I have to do 6 times the whole thing. So that would be 60 minus 6x. Then what would I do?
Take away that.
Add the 6x to both sides. So 15x equals 60. Divide by 15. And that goes in there 4 times. So x would be equal to 4 in that problem.
Do we usually have to solve those?
Usually, yeah. Usually you won't just be setting it up. You'll have to solve as well. In the bottom one, this is that corollary that says if I have parallels that are cut up by transversals, that it will cut them up proportionally. And what would be a proportion we could set up here? It's actually a 15, not a K. That's bad handwriting on my part. So y over 15, but it looks like a k.
Sorry.
It is a 15, but it definitely looks like a k. And then 14 over 10. That would work. That's not the way we set it up in the notes, but it's consistent. And that's the important part about these proportions, is that we're being consistent in what we do. When we set it up in the notes, we did something like top to bottom, top to bottom. But when we studied proportions the other day, we learned that you can read proportions either up and down, or that it's true to read them sideways as well. So those say the same thing if we start reading the problem sideways. Okay? So it's fine to set them up in different ways. So if you're checking your work with your friends, they might have set it up differently, but you should end up in the same place. So how would we solve this then?
Which one?
Well, the method would be the same, but we'll just go back to the original one. So how would we solve? Cross multiply. So that's going to give me 10y is equal to 15 times 14, which I don't know in my head. So it's 210. Good. Y is equal to 21 then. Okay. Questions?